you are invited to paper innovative methods of assessing the academic success of students in higher education institutions. In the article, use innovative possibilities of assessing and predicting the academic success of students in higher education institutions in terms of formation of human capital are investigated. The proposed multinomial logistic regression model allows to assess and predict the success of students based on the obtained estimates, and taking into account various factors. Educational data mining plays an important role in the development of the learning environment. The main problems faced by higher education institutions are analysis of learning outcomes, quality education, evaluation of student performance, strategic decision-making, and formation of human capital at all. Different methods of machine learning are used to understand and overcome the main problems. To assess the academic success of students, a relationship should be established between factors and academic success. The following factors were used in the study: an assessment of the student's presence in the classroom, student's grade in mathematics, student's grade in computer science, assessment of the student's living conditions. Logistic regression allows determining the group of students' academic success. In addition, logistic regression makes it possible to consider the probability that a student will be classified as a certain group's success. The probability of occurrence of an option is described by a polynomial logistic model, where bj, unknown parameters that we will evaluate. x1, assessment of the student's presence in the classroom, behavioral factor. x2, student's grade in mathematics, intellectual factor. x3, student's grade in computer science, intellectual factor. x4, assessment of the student's living conditions, behavioral factor. To identify the model, 1. Usually use the rationing bj equals 0. This is one of the features of building a polynomial logistic model. According to this feature, only the coefficients of the first j dependencies b0, b1, bj1 are calculated, in accordance with 2, which the first j probabilities p, y equals 0, p, y equals 1, p, y equals j1. The probability of choosing the last option p, y equals j, is not calculated, but determined separately using 3. The coefficients of the model are estimated by numerically solving the plausibility equations. The solution of this system is carried out numerically using the Newton-Raphson method. The main data for the statistical analysis of the educational process are data on the success of undergraduate students at the Economic Faculty of Ivan Franko National University of Lviv, Table 1. Analysis of the data showed the presence of multicollinearity. Therefore, it is advisable to use the method of principal components. The main idea of the method is to replace highly correlated variables with a set of new variables between which there is no correlation. The new variables are linear combinations of the original variables. We find the connection of the dependent variable y with the main principal components as E3 and E4, defining all principal components, and rejecting those that correspond to small values of characteristic roots. To do this, we build a model of multinomial logistic regression. The parameters of the obtained multinomial logistic model are as follows. Let's write down the analytical expression for the constructed multinomial logistic model. The resulting expression can be used to assess academic success of students at different values of the factors. In particular, figures 1 and 2 show the dependence of the studied indicator when changing the factor x3, student's grade in computer science, for certain values of the factor x1, assessment of the student's presence in the classroom, and the fixed value of the factors x2 and x4, x2 equals 6, x4 equals 3. Figures 1 and 2 show an increase in the probability of receiving a better grade, and a decrease in the probability of obtaining a bad grade in the subject of information systems in management, given the increasing in the student's grade in computer science. Different values of the student's presence in the classroom have a great influence on the dynamics of increasing the probability of getting a better grade. We can say that the key to measuring student achievement is assessing student progress by measuring positive changes in the assessment of the student's living conditions and student's presence in the classroom, as well as gradual changes in grade in computer science. Figures 3 and 4 show the dependence of the studied indicator when changing the factor x1, student's presence in the classroom, for certain values of the factor x2, student's grade in mathematics, and the fixed value of the factors x3 and x4, x3 equals 7, x4 equals 2. Figures 3 and 4 show an increase in the probability of receiving a better grade, and a decrease in the probability of obtaining a bad grade in the subject of information systems in management, given the increasing in the student's presence in the classroom. Different values of the student's grade in mathematics have a great influence on the dynamics of increasing the probability of getting a better grade. We can say that the key to measuring student achievement is assessing student progress by measuring positive changes in the assessment of the student's presence in the classroom and student's living conditions, as well as gradual changes in grade in mathematics. Now let's evaluate academic success of students through the developed regression model of an academic success of students. Information for assessing academic success of students is presented in Table 3. In the first case, we are likely to receive the grade of satisfactory. In the second case, we are expecting to receive the grade of good. It is only in the latter case that getting the grade of unsatisfactory would be most likely. It is possible to predict individual learning outcomes, to evaluate student actions and differences between actions, to assess factors related to success, to create an individual learning plan through the constructed model. The presented approach has a solid foundation for improving the effectiveness of student learning. We can rely on modeling results to develop pedagogical frameworks that help students develop an approach to learning.